So we're going to look at what it means to have a negative in your indices or power. So we're going to start by looking at a pattern here. So we're starting with 9 to the power of 3. Sorry, that's a bit wishy-washy. Which of course is 9 times 9 times 9. Then we have 9 squared, which is 9 times 9. Then it's 9 to the power of 1, which basically just means 9. And then we've got 9 to the power of 0. Okay, so let's just stop and look at that one first of all before we get to the negatives. So what we can see happens if we go in this direction is that each time we move up, we're multiplying by 9. So conversely, if we come down, each time we come down, we are dividing by 9. And so if we do 9 divided by 9, we get 1. And so this is quite an important fact on its own. Anything to the power of 0 is always 1. So now, if we continue this pattern down, the next logical conclusion to go to is 9 to the power of minus 1. And then if we look at our pattern here, what do we need to do? We need to do 1 divided by 9. Now don't overcomplicate this. 1 divided by 9. It's that simple. So if we go down again, 9 to the power of minus 2, we'd have 1 divided by 81, because we've gone down 9 more. We're divided by 9. Let's just show that over here. So 1 over 9 divided by 9, which is the same as 1 over 9 times by 1 over 9, which is 1 over 81. Now, what I want to do is write this in indices notation. So that's 1 over 9 squared. So hopefully you can predict and see that 9 to the power of minus 3 will become 1 over 9 to the power of 3. So we can see that each time the effect that this negative is having is making it so the negative leads us to 1 over the positive version. So 9 to the power of minus 2 is 1 over 9 squared, the positive version. 9 to the power of minus 3, 1 over 9 to the power of 3, the positive version there. So that's what your negatives mean when they're in indices. We're now going to look at what it means to have fractions in those indices. So I'm not going to do the whole diagram again, but we're going to look at a little bit. So remember that pattern that we had before. So I'm going to start this time with 9 to the power of 1, which is 9. Then I'm going to leave a gap, and we're going to have 9 to the power of 0, which remember is 1. So our fractions are going to lie in between these two. So we're going to demonstrate this on 9 to the power of a half to start with. So we're going to figure that out. Now, in order to explain what this is, we're going to look at this using some of the basic rules we use with indices. So if I take 9 to the power of a half and I multiply it by 9 to the power of a half, or another way I can see that is I'm doing 9 to the power of a half squared. So whichever version you prefer to look at. So remember, when we multiply, we add the powers. So a half and a half is 1. And when we have it in brackets like this, we multiply these two things. 2 halves are 1. Either way, we get to this. Now, it's probably easier to understand if we look at this bit here. So if we square this, we get 9. So something here, this mysterious 9 to the power of a half, when we square it, we get 9. So I think you can easily see that that is 3 in value. So 9 to the power of a half is 3. But what I want you to understand is the general principle here. Okay, so 9 to the power of a half is 3 because it is the square root of 9. So if we take something and square it, we get this. So to go back to the beginning, we must square root. Now, I'm not going to go through all the other different ones in the same way, but you could if you wanted to. So 9 to the power of a third is the third root of 9. 9 to the power of a quarter is the fourth root of 9, and so on. So all fractions are some form of rooting. Very simplest, it's square rooting, but it can be any power at all. Now, we're going to have a look at a couple of practical examples now of how all of this stuff works when we combine it. And forgive me for a minute, I forgot to get the extra bit of paper. Okay, I'm back. Sorry about that. Right. So let's just recap there. So for example, if I had 4 to the power of minus 2, that would be the same as 1 over the positive version 4 squared. And if this was in an example with numbers like this, they would then expect you to actually work out the bottom there. And 4 squared is 16, so your final answer would look like this. Okay. Now let's do a fraction one. So let's say we have 27 to the power of a third. So that means we've got to work out the third root of 27. Now they expect you to cope with small powers of 2 and 3, possibly even 5. And so what we're trying to guess is, if you like, what mystery number to the power of 3 will give us 27? Okay, so it's partly guessing, partly you need to just learn these and have experience with this. Okay, so it's 3 times 3 times 3 gives us 27. And so 27 to the power of a third, which is the third root of 27, equals 3. Okay, now typically these actually come in a more combined version. Okay, so we're going to look at what to do with something like this. So we've got 16 to the power of 3/4. Now we haven't done one which has got a number on the top of the fraction. How do we solve this? We do this by using that brackets rule to do with indices backwards again. So I'm going to split this into 16 to the power of a quarter, all in brackets, and outside the brackets we're going to get the 3. So remember, the rule is you multiply those two together, so 3/4 is 3/4. Now we've got that separated out, we're going to do the inside of the brackets first. So 16 to the power of a quarter is the same as the fourth root of 16. And the fourth root of 16 is 2. 2 times 2 times 2 times 2 makes 16. So we've got 2 to the power of 3 now that we've figured out the inside. And 2 to the power of 3 is 8. 2 times 2 times 2. So we've used this bracket rule to separate the parts out to do it. So here's another example. So we've got 8 to the power of minus a third. So this time in the brackets I'm going to have the 8 to the power of a third, and outside I'm going to have minus 1. So minus 1 times 1/3 is minus a third. So what have we got inside the brackets here? We've got the third root of 8 to minus 1. So the third root of 8, if you look at the above example, we've got the clue there, is 2, because 2 to the power of 3 is 8. So that means we've really got 2 to the power of minus 1, and 2 to the power of minus 1 means we've just got 1 over the positive version, which is 2. So 8 to the power of minus 1/3 is actually just a half. Okay. So often these more complex ones are the ones that you will see, and it's all about using these brackets to separate out the parts. And what you want inside the brackets is the simple fraction bit, and take everything else out. So just work out what you have to times this by to get to what you started with. So this is how we work with negative and fraction indices.